Yes, good evening, everyone. Is it audible?
Yes, sir. Yes.
We'll wait for a while so that other can join. Can you mute yourself? Good evening. Welcome to that live session that myself, MD Asjad Raza, and the PMRF scholar at Tenerife Trichapalli. And so, this course is actually for machine learning, and this is application-based course that machine learning for engineering and science application actually. And like how the course and what will be the agenda for the course and all that we will discuss, and then how it will go proceed in the coming 12 week, and how this session is going to help you, and how you can utilize the sessions and all. And if you have some doubt regarding the assignments or any doubt regarding the lecture that you have seen for the first week or second week, like first week, and it will go the proceed on, so that we will also discuss. And like how I will going to proceed, or how I'll like take the this session forward. That's I all so that's I will explain also. And in the last also we'll solve some problems that might be helpful for your for your current or life assignments and all. So before jumping into the sessions or starting the sessions and all, so I want to get familiar with with you guys, that from which background, from where and all, and then what you're expecting from this course or what you're expecting from this sessions also. So we'll get more familiar with this. So like, can you please one by one, or maybe few people just tell what is your background, and then what is the expectation from this course also, and then what do you want to learn, whether that you're coming from that particular background like a CS or IT, or you are jumping from the other branch to the to that into the field of data science or maybe the machine learning field and all. Okay, so we'll wait for some time that let them join and few please start like someone that you can speak also and you can tell like how and what is your expectation from this course and all. Then we'll once we'll get to know we'll get familiar with the like with us like with so then we'll go ahead with that how the session will proceed and all. Yeah, that will do. Need more example. Okay, so it's a course that the coursework for the PhD criterias. Okay, and if you're having background in the mathematics. Okay, okay, we'll solve the real-time problem that we need actually, and we will talk more into that application-wise only at the course itself, saying like how it will be application in the engineering and science application. So we'll discuss in the that what we can say biomedical also. Okay, ME that Master of Engineering in the ECE, working as a lecturer. Okay, so for the PhD coursework itself. Okay, few more people like then we can go ahead with that. I'm associate professor. Welcome, sir. Like CSC, how to use deep learning in the recent area of research and all. So that's and uh, and we'll see this also that how that deep learning and then ANN or maybe that machine learning or AI itself is the broad area. In that part, that's so that deep learning will come into the picture, and we will take the real life examples also like the people are doing with that Tesla that or ADAS is there that automated driving systems and all, and even we'll see with the like how it's going to use in the biomedical field also medical research also. I'm from the mechanical background, but my research area is some more of the biomedical it's sports biomechanics and working in the biomedical instrumentations and all. Okay, so from my research, I am learning this course for the how to process some image-based classification type example like CNN and all. Okay, we'll see. And fourth semester from the third tier college. Okay, I'm the weekend. I just wanted to say the course amazing, wonderful architecture from the mission. Okay, so we'll go from the scratch. Like even though if you don't have the background of the anything or like something will expect from you, like that you should have some idea that regarding of that algebra. Like it's a something called metrics. Then we'll see the tensors also, and we'll expect something from the like in the MATLAB also. So sixth semester CSC student, second course to learn more about the ML and application part of the studying ML. Okay, so that is your so that I will give just a brief of myself, little bit, not much more, as I'm the PhD scholar and PhD scholar. Like I'm also PMRF fellow. Just 1 minute, I'll give it. It'll take some time. Let the people join, then we'll get. Okay, PhD scholar from a mechanical background. Checks informed neural network and all that we're going to use in the okay fine. I don't know about any idea about the MATLAB. And this okay, will you speak all this thing and all that how much that we need or how it will go and all. Like, because that once we take the examples and all. So we'll deal with the something called pure of maths and all. And the same thing we're going to apply into that MATLAB so that we can get the results as much as fast possible. I'm for semester student from the ISC branch. Okay, tell like where you want to apply or where you want to see after doing this course, once this course will end or that you're going to write the exam. So at what or which place do you want to see yourself? So that's also will we make some projection that how it will go and all. Accordingly, we'll solve like remote sensing problem. Okay, GIS and all. Yes, just first step when discuss. Even like how many are familiar with the MATLAB? Even before the MATLAB, I'll expect like some background regarding that maths or algebra specifically. MATLAB and Python a little bit. Little bit regarding the MATLAB. Python with the collapse. MATLAB Python. How much linear algebra is needed for this course? This we will discuss, like how much exactly do we need. It's more of a tensor or matrices and all, or decomposition of and all that we'll see. Just know basic syntax only in the MATLAB. So we can do Python in assignment, but we have to follow. I think in the assignment mostly you have to follow with the MATLAB, or even you can do because that's with the multiple choice question. So you can do in the through MATLAB or even with the Python also. Major no issue. Okay, so we'll be expecting like people will not join much. So now we'll see at how the things are going. Okay, it's some credit real-time problem that we need. Okay, real-time problem that we need. Even if you have some idea that we can work on it, or either I will try to take as much as possible. Like once we'll proceed, like we'll segment this course into the 2-3 parts, as sir in that lecture might have segmented. Similarly, we'll take where it going to useful in the either in the medical field or even in the science also, even the physics also that we'll see, and we'll try to solve. It's like a hands-on problem that we'll do. And ME in that Master of Engineering in the ECE, working in the lecture Polytechnic College had that AI. So I want to learn machine learning from okay. So that will be helpful because it's a foundation course. So Only thing that some expectation from this will be there, that you should have some that algebra or the MATLAB. If you don't have like any background of that ML and all, so there is no need to worry, because we'll start with the algebra also, but will not go much of detail. But so that whatever we're going to discuss and all, that is going to help in our for the further classes or the coming classes and all. So, how to use deep learning research in the recent area of the research? So can you specify what is that recent area, like in which area that you want to work, either in that pure CSIT or biomedical field or medical field, or maybe the mechanical or wherever. So it, because deep learning can be used in the different fields also. So when it gets guest is there, I'll just let in. We'll see deep learning, like in the recent area of the research, we'll take a different area. Maybe we'll take pure CSIT problem, or maybe that IoT, or maybe the sensors development, or maybe that automatic that machines or ADAS and all that we'll see, because the people are coming with the Tesla and all. And there's a part there that the research scholar, Mr. Purpose actually, and the electronic vehicle. Okay, so that can be used in the EV also, for the console, or maybe that sensing, like how like now the cars are more of it's coming with the sensors and all, that we can play more of that. So, and this is scientist working in the remote sensing also. Okay, GIS problems and all, having physics background. I want to apply okay, that also we can do, because it's a more of CNN that we will use. That will tell like which algorithm and will which where it will work and all. If time provides, please do some project with the help of the code. Okay, that will do it. We'll take some real time, for example, even with that what area like what area I am working on. So from that also, I will take the data and then we'll solve the problem. We'll play with that models and all, and then we'll compare with that how the things will work and all. And even with the coming with the deep learnings also, we'll play with that also. So we'll take uh, some project, like we'll take some data, we'll try to we'll try to train the model, and we'll see that how it works, and then how we can that manipulate the parameters and all, or hyperparameter tuning or optimizations and all, so that our computational cost should reduce, and we can get the that the fast results, and it should be accurate enough also. So because that people are going to more of that is the automatic and all, so people will be expecting like whatever the expect that the model is going to train, they should give the better results, accuracy should be high, or so there is no room for the some sort of mistakes and all. Okay, for my research, I am learning this course for how to process some image-based classification type image control. Okay, so more of the classifications, maybe that's also we can deal with the CNN and all, and in like sometime we can go with that. We'll see how the things will go on. That will explain that this course will be more of like we'll take from the starting with the maths on all. Like it's not the black box type. We'll be having toolbox that like a MATLAB have, and then we'll give the data, so that the toolbox will work as a black box, and then it will give the results. But no, so that we're going to play with the maths, how that what you can say, that the layer hidden layer, or maybe the CNN or RALU, or maybe that how it will work, so that we can play there. It's like something play the background, like we'll do the coding like based upon that, and then we'll go. So we'll try to not go much that as a black box type, but we'll more into the what you can say, we'll play with the maths and all. Okay, then 6 semester student course learning for the ML. Okay, that we'll see. Mechanical department, that we want to learn in the physics informed neural, that network will be there. Okay, fine, that we will also see. So before jumping into the physics, we have that inform. So we'll discuss that what is the ANN and what is that neural that is a network and all. Okay, mechanical engineering student. I'm passing on this question. I'm doing okay, fine. Okay, so that you want to apply for the CFD problems. Okay, that we can also do. I don't know, but we're expecting like okay. Before starting the course, if you go to that course content, so in the first week course, before that there is some what you can say that for the access of the MATLAB or even for the basic training also that you so that you go to that, so that it will be what you can say recommended like that. Just go that training is actually free that you can do it there, and it will give the brief idea so that at least if I'll play with the syntax or maybe that any operations and also that that you should have the idea like how the syntax is changing. If you are fully blank, so that might be a little bit difficult, but you will be able to grasp it because it's something called more of maths or derivations will be there. But once I'll go take that example into that MATLAB. So what will happen if I'll change from the one operation to the second operation? So I'll change the syntax or the syntax or maybe that any operations will change. So that might be. So I'll be recommending you like just go and do the basic training course and then come back. So it will be helpful for you. Okay, mechanical student HM. Okay, ISC branch. I want to implement ML in the IoT project. Okay, that also you can do IoT project and all that. This course will be like after this completing this course, you will be at the place that from that place that you can go in any field, IoT field or remote sensing and all. Wherever you want to go, that you can go, and it will be good. Okay, digital twin, like you want to play with the automated and then with the physics also, or maybe you want to go with the like traditional methods also, digital twinning and all. Because now this is a new term or fancy term in field of the AI and all, and even like some new terms is coming like just a similar way in that winter season of like in the starting of that somewhere on 1940 around or that conference happened first conference happened, so that's also AI was the first like introduced. So similar way digital twin also is there. Okay, where we are. Okay, micro paleontology background, haven't implemented anything research. Okay, fine. So that's some more of microplanting is something maybe agricultural part. Okay, power electronics and okay, control part, CFD and all. I know the basics of simple programs. Okay, fine. MATLAB and Python, the both language are fine, but I'll be more discussing because I'm the more familiar of the MATLAB. So I'll be discussing all the whole problems or maybe the examples, or I'll be working as a live project also. So that will be more into that MATLAB only. So I think the syntax or maybe the operations and all that will be more of similar from the Pythons also. But I'll be much into the compatible for my that what you can say MATLAB also. That for that the linear algebra, how much do we need? So I'll saying that we need more of that matrices and the tensor, because in the ML part, it's really full of that we are going to whatever the scalar vector and all that we're going to convert into the tensor, and that tensor will be the input, and the same that output will get as a tensor only. So it's a more of that that we'll discuss around the tensor itself. So in that also that if you have seen in that 12th class maths also, so that you have like a determinant, cofactor, or inverse of the matrices, or maybe the decomposition of the matrices, or eigenvalue, and even we were having transpose and all, and some that properties are also there. So this is all thing whole around it will go. Okay, earlier I used the MATLAB, but currently using the Python. Oh, it's okay. You can work with the like Python, but this like 12-week session it will go all together with the what you can say. So it will go with the MATLAB only. Please guide us on how to do the assignment using Python. Okay, I'll be like discussing more onto the what you can say that if time permit, and then all after the MATLAB. So then we'll tell you some sort of that materials and all that will help. Python with the TensorFlow for the machine learning seen in a form. That's good. TensorFlow, because TensorFlow is actually that they have, and then okay, that we can do. No issue. Is RL like reinforcement learning, deep learning, LSTIM and all will call into MATLAB. So that reinforcement learning and deep learning that will be in that third part, maybe the 10th, or that will be the it will be covered, but at what extent that will be once the time proceed, because it's a introductory course for the machine learning to enter into that machine learning. So will we try to clear up the idea, or will get the basic clear so that we can use in the DL or the RL and all, because LSTIM is all around like sequence, like time series problems and all. Like we can play with the when the time proceed, how the things are going into the continuous problems and all. That will go. We'll discuss, and we'll be more into like the traditional learning and so on. We'll see. Okay, so I think it's good enough. Like I'll be telling about myself. Like I'm doing my research like in the field of biomedical engineering, and I'm working on the like sports biomechanics, and more of area of my machine learning area is there. So it's the predictions of the fatigue that I'm dealing with the muscles and all. And it's not fully biomedical. I'll say biomedical that instrumentation I'm using it, and that I want to predict the fatigue for a sports person, or maybe those who are having some issue with like maybe they will get fatigue, how fast fatigue will happen, how like the fatigue that can be done through that people are having the what you can say, so that the watch and all. But I'm going much of the physiology problems, like how the muscles will break down, or what's happening with the muscle, that oxygens and all. And then accordingly we'll see with the muscles that it's more of going with the physiology, and with the um, that some sort of biomedical fields will be there. So before taking this session, so I took two sessions for the NPTEL itself. That was the statistic course, because that if you are if you'll ask like what is the prerequisite for this course, first one is that algebra. Second one will be the probability and statistic. Okay, and third one is the optimization. So before like this course, like I'm taking this is the first time, like and but I took the course and all that I have the familiarity with that. So what was that? Like it's a that statistic for a biomedical engineer. That one I took, and the second course was the biostatistic and design of experiments. So more of aligned with the biomedical field. So that whatever that the problem will take, more of it will be the medical field will be there, and we'll see that some other problems also it will be going to like it will go more of similar of that field only. Okay, so so shall we start, or we'll see how the agenda and how the things will work out, like how the scores will go proceed in the coming that span of the 12 week. Shall I go? I want to use the ML tech in the sensor failure predictions. Okay, fine. So it's a predictions for the that is the sensor failure. That can be of application name that automatic, like any washing machines or maybe any sensors like that. Okay, fine. So that also that will be very so this course will be helpful for you. So shall we go? Yeah. And I'll tell one thing regarding like that how that after this session, like that this is that going to be Swastan is going to what you can say record it, and that will be uploaded on the YouTube AI in IoT. Okay, fine. So this lecture is going to upload on the YouTube, and whatever the content I will use for this session, that will be also in the drive link, so that you can get access to the course and the content that so that you'll get from the dashboard. Okay, so we'll go ahead with that. Just 1 minute. Okay, so this is the first week for that machine learning and that the for the science and application that, and this is my some sort of like background that I have discussed like some teaching and outreach programs that course for that at Trichy also I took graphics quality control basis of mechanical. Yeah, so this is the course actually, and that the professor biologist Srinivasan sir and Professor Ganpati Krishnamurthy sirs will take like that you can get the access to the course. Will go. This is the course actually. So before I'll tell the agenda and all, I'll be telling you. So how to get the MATLAB access? Actually, if you see, once you that enroll the course, so that you'll be having the access of the MATLAB, that is the MATLAB online. So that let's say if some people doesn't have the access to the college, or maybe those who are not into the any organizations or college. So during this period of the course, you can have the access of the MATLAB, so that whatever the problem will do, or that you want to do for your assignment problems and all, so that you can access. So first step, so that you can go through the MathWork account. If you have the account, so that's fine. Otherwise, so that you can create the one account there. So after that, we have to follow this link, and that we can go. So they will. So this link is going to give till ending 10th of May 2026. They will giving. So whatever that account that you have created, just go and I'll sign in through that one, and so that for this till the 10th of May, that you will have the access for the that MATLAB course. And after that, once that, so that is the that the browser requirement and all, that will be having like whatever the system like that we're going to use. And second thing, once you get the access of this course, if someone is very new to the MATLAB, so these are the some courses that the company is giving for free. So first one is that MATLAB on ramp. It will be giving the basic idea how that basic operations will work, like that what you can say, addition, subtraction, and all. And it's on ramp code, like it's a deep learning, image processing, and then machine learning. So these are the free course. Yes, please. Anyone want to tell anything? Okay. So, so that you can get, and please, if you are not having any ideas, at least go through this course. This will be taking only 1 or 2 hours itself if you are going to practice it. So so that you can have the that basic idea of that machine learning, like that MATLAB and all. Okay. So once we are done with that, so what will be the content of this course? So the content of the course that we are going to divide into the three part. Like part A, that we will discuss of ANN or RNN and CNN and all. Then the second part, like it will be going to be a dealing more of the traditional method, maybe that Bayesian, or maybe the SVM, that like KNN, GMM, and all that we'll discuss. And the third part will be that advanced method like auto encoder and all, and generative adversarial, that the network will be there. So if I'll say specific to the how the week will proceed, so week one, week two, and week three, it will be more of the linear algebra problems in there, or maybe the fundamental clearance will be there. Okay. So in that first, like mathematical basic, like that will go. What is the introduction to machine learning? Like what are the history? Like how from what time it got proceeded, and then that where we are, because that we started like that at time of the Stone Age only. if I'll tell you that history, or if you have went through the lecture, so that you might have seen like sir have started from that uh, 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 Radha Bhoj. So they were saying about the robot and all. Then from that we enter and all. So first 1 to 3 week, it's going to be a intro to the ML. Then we'll discuss that algebra. Then it will go with the probability. So that is a very important part. Okay. So then after the probability, because why it will be the very useful, because once we'll go to the base class, if that is the name base and all, or maybe that feature importance and all, that we have to deal with that one particular probability also. So that is a very important part and all. So that's why whenever if you're going for the any machine learning data data science and all, so people will that start saying that you first start with the fundamentals, that is the algebra. Then they will ask to go to the statistic and probability, statistic and probability, so that you will be having the idea like how to that going to create the threshold and all. So once you are going or that once you're that familiar with that statistic and probability, so it will go to the computational basis, like it's a optimization problem, or maybe that how we can optimize the that ML models and all. So because if you go with the traditional and also that the parameters will come into the picture, or maybe that number of neurons and all. So that might be not optimized one, because in the ML and all that we're going to always follow the hit, and that we're going to follow the hit and trial method. So sometime what will happen, like we'll get the some parameter, but in that case, that accuracy will be the very less. So what we'll do, we'll try to optimize so that parameter. So that parameter will say hyper parameter, or will tell the model tuning and all. So that all will discuss like how we can do that tuning of the models and all. That will discuss and all. Then we'll discuss that packages of the machine learning. If I'll talk about specific to that MATLAB, so we'll be having deep learning toolbox will be there, ML toolbox will be there, statistic toolbox will be there, then all. And even with we'll see in that ML also, we'll be having different types of that ML will be there, like supervised learning, unsupervised learning, or semi-supervised learning, and all that we'll see. So then week 4 and 5, it will be going to be more of discussion on the neural network. Neural network. So it's going to start with the just 1 minute. I'll see what is the content now. Yeah, it's easy to get it, but for this course, this particular course, that we'll discuss fully on that MATLAB only. So today is the first session, so that's why I just wanted to get the familiarity with the course, how it will go and all. So first, then the week fourth and all that we'll discuss the ANN, like a neural network, and then the 6, 7, 8. It's a CNN part one, CNN, and then RNN. So this all three will be the variation of neural network. We'll discuss in the detail. So that we will discuss in the detail. Okay. So then that week 9 and all, week 9 and week 10, it's actually a traditional ML model. Like in that, we'll be starting with the Bayesian regression, binary tree or decision tree, and then RF that is called that the uh, uh, random forest, and then support vector machine. Then we have that naive Bayes and all. Even we'll discuss about the KNN also. KNN that will be having more of a GMM Gaussian mixture that model we have. Okay, so that the ninth and 10th week will be the going to discuss more of the classical models and all. And the last 2 week, so that's where that our that advanced problem will come from the picture, like auto indicator or self-supervised learning, or maybe that reinforcement learning, or in that only we'll go with the LSTM and all that with, so that all we'll see. So auto if encoder it's a part of what I can say self-supervisor, like that will not having that much of data, so we'll try to self-supervisor, then we'll go ahead with it. Then so if we talk about the books and reference, so that two books it's very good actually. So that the first one is the that's a good fellow. I'll tell you like so that you can go and download the book. So this book is actually it's a very important book, or maybe the very easy book to get. Get into that if you are going to beginner of that. So please follow through this book and all. And if I'll tell you that second book, the Christopher Bischoff and all, so that book is actually a very good book, but it's a bit of like technicality is bit of more. So we might be not able to get the in first instance. If you're going to the again and again, that will get it. And even with the sometimes we'll take some problem from the Google Scholar also, and we'll try to solve what the people are doing in the currently and all. Okay. So this was the whole I told about the how to get the access of the matter if someone doesn't have the access. So you have to click that link where you have that like from the like it's a dashboard, and the same that email ID, so that you used what you have done for the registration of this course and all. So once you are going to that verify and all, so that you will be having that access of the MATLAB till the 10th of the May and all. So that will be going to be useful. And how that if you are not having any idea, so that just go to this core course and then you will get the basic idea. Then we can go ahead with that. So can you someone please tell what is the machine learning actually? Okay, now we are going to start the things and how I will proceed. So what I will do, like whatever the brief. So how I'll proceed, like I'm going to start the session like what we have done in the last week, and the same like in the current week. What was sir taught? I'll be giving the brief idea of or the summary of the full week course, and based upon that, we'll like solve some problem, even like some type problem, and so then time permits. So the same thing I'll done on the like on the that the software also. Okay, so can anyone tell like what is the like that idea of machine learning? Like, can you tell some definitions and all? What is the machine learning? Just tell whatever you've understood from there. When someone is saying that the machine learning, so what do you understand? Like, what is the thought process is coming in your mind? So just tell, like, we'll discuss that. We'll have two-way communications also. So we'll get to know like how the people are thinking in the different way. Replication of the human recognition. That's also very good. Yeah. Can anyone tell what is the difference between the human and that machine? Or what is similarity between? No finite states of the rule. Okay, fine. Can anyone tell the what is the similarity between the machines and that the human? Okay, trading will be given for the machines. Okay, feeding data to the machines so that they will make their own decision. Okay, anything? Wrapping a process by which a system improve its performance. That's very like that's also convincing. Trying to make machines behave in a human way. Okay. Trying to make machines behave in a human way. Okay, fine. So program that perform better with the experiences. That is something like bookish and all. So human being also like they'll be having some learning process. They will be going to get through the past or experience. The same way we are trying to the like we're going to give the training to the machines. So it's something volume data set which machine will be trained. Okay. Train the machine to understand the system and to improve the performance from the learning. Okay. Even with that human being also, they are in the same phase. Like they are when they to give, like when they're going, but then after like it's going to be they will learn or the people will feed the things. Okay, this is the car, this is the battery, or this is the mom, this is the dad, or this is the sky and all. Based upon that, we are going to behave, or that will take. So similar way, we are trying to feed to the machines so that we can it will be giving the better results and all. Okay, machine analyze the past data and it fed to the future things. Yeah, or they will try to create the rules. Like we'll give the what is the output and all. I will going to give the data label and we'll get some sets of rules and all. Handle uncertainty and noise, generalize unseen data. Yeah. Okay. So if I'll talk like how it will go, so that machine learning, it's going to be like a replicate the activity that's requiring human congregations and all. Like whatever the human try to behave, same thing we are going to replicate into the machines also. So one thing that there, whatever we are going to feed or train the things, that will going to be like that way only. But if you see in the human, like they have that sensing and like they will be changing with the different like experience of past and all. So if I'll talk about the how that where you're going to application and all, so real world it's going to be in the traffic predictions also, and even with the automated translations also, virtual personal assistant also like we have the Siri or maybe the Apple Voice or maybe the like the things are there. Even the people are like even in the Google also they are going to deal with the web search and that even if you see in the Amazon like they're giving the recommendation like that what you have searched or what you have bought it actually. Even that online fraud detections also, that's a classic example also that we have a spam detection. That so that's a very classic example that we have. Medical now the people are using in that medical diagnosis also. Just 1 minute. Not the rule based. Automatically learn the logic. Okay, fine. So even that we can use in the that biometric, the face recognition also. Till the starting and all that we were having that the data scarcity was there, but now the that so that the Google or the Facebook or that OpenAI they have the plenty of the data, or even they are doing the data mining also. Can anyone tell the what is the data mining? So if that before jumping into that, what you can say, the, what did that, what you can say, like that the history of what you can say, that AI and all. So there is a one that law is there that's called Moore's law. Anyone have the idea what is the Moore's law? Moore's law is actually talking about the resources. When we were starting of that, so we were having very analytical engine. When the time got processed and all, now we are coming with the supercomputer or maybe super GPU also. Like now, based upon that NVIDIA GPU, analog ASICs and all that, people are coming with that. So means once the time transform, that how it's going. Like it's they're trying to calculation per second per constant dollar also. Like they're effectively cost effective also, and even that we'll having supercomputers, super GPU also. If you are going to that listen NVIDIA CEO, they are coming up with a very smart like chip and all, so that we don't it's very sophisticated like that station for that what you can say that super computing and all that we can in the single uh, the system itself that so that we can do very high end that the programming also and all. So this is how that all the resources and that how the time progress and all. So if will come, so when once it started computers and all, what we thought, people wondered like whether this machine is going to intelligent or not. Over 100 years, that was one before built. Like it's something people was like first confident like it's going to be like whether it's going to behave that the machine will behave as a human or not. But now if you see like it's the machine, what they're doing, they are mimicking the human. If you see that robot or if you see like they will try to whatever even now they have the feelings also like they will feel like how the things and even they will going to recognize the real world people or that the real time data also. So means and now that people are doing with the AI in the many practical applications such as intelligent software or to automate that routine or that understand that the speech or images or speech like that the Siri and all that will play with this that and images also that we can see like people are doing with the biometric or the facial recognition and all. Even people are doing with the diagnosis also. If you're going to define and all. So if you talk about so what is machine learning? If you talk about machine learning is the field of the study that gives the computer the ability to learn without being explicitly programmed. Without doing any programming, what we'll do, we are going to give the capacity based upon the history or past experience. We'll be going to tell again and again, this is the things and then how it will work and all. So if I'll talk about like what is the history, can anyone tell like from where it started that just 1 minute? I'll open my camera actually. Fine. Hit discover hidden patterns, increase in number of patterns. Fine. Okay. So can anyone tell like how that AI evolved? If I'll talk about that robot, so the concept of the robot that the robot came at the Raja Bhoj. If you heard about the Bhopal like kings and all that time, so they talk about that how that robot and called that's what called prehistory. Okay. So that was the till 1901. And in that only, like they were talking about how the robots replicate the humans. But it was not up to like that context and all that, but people have talked about that also that time. So and then birth of the artificial intelligence, if I'll say, it is that period of 1900 to 1960. Okay, so 1940. Shall I deal with that, or shall I go ahead and then I'll tell how the machine learning will work and all? Can anyone tell? Because it's the more of less how the AI got evolved and all. Let's talk about the chess playing. That so that was the first ML or AI application came. So if you have heard about the IBM and then Watson problem, then there's so they were playing with the chess that. So that IBM have created one that application, and then they were like a beating to the Watson and all that. From there, that's a boom started and all for the AI and all. Is it? And I will tell you that if you want to get the brief history of that AI and all, to go and see the imitation game. That's a Alan Turing theory, that the birth of that the computational that the computer came, because that to uh, evade the Soviet and all in the Europe and then US have this is how the imitation theory in from there only information or number game came. Information or number game. From here only it came the theory of computation. Then in the 1950, like in the 1950, cybernetics came. And then after we are having that first neural network, it was back into 950, that is 1951. It was the SNARK, SNARK. It was the stochastic neural automatic. Uh, that's the reinforcement calculator was there. So that is the first time that people have used the neural network. Like it's working at the like brain, and then how many that so that the neuron we have, then we can play with that and all. So then it came that a theorem of the proving machine, and in the 1957, Roosevelt actually they played with the two-layer ANN, and that time the concept perceptron came into the pictures and all. Okay, and just 1 minute, I'll take one extra page, not more. Then the one period came actually that's called golden year, 1960 to 74 actually. In that only it was the based came rule based program. If you see the example, it was the playing chess, because in the chess we have the certain rules are there that we can't avoid, and that we can play with that. Even helping in constructing the organic chemistry model, because the organic chemistry, whatever the things that the chain reaction should go, it they have that fixed based rule, so we can't play with the our own rules and all. So it was the like it's a golden era or golden rules that the people are evolving. Golden chess 1962 expert system, yeah. Solving the that word problem in the algebra. Even we were trying to understand that natural language also. Okay, we have to cover at least some part of the algebra today, so that will be helpful for your what you can say assignments problems and all. Even general purpose that the mobile remote also. Okay, so then after the era of 1974, it was the first AI winter. So problem with the that we were having that for the AI and all, that time the problem was that we were having the low computational power. If you see that our computer and PC that came into the 1980 or 1990 around, so we were not having much of control on that. So then we were having that combinational explosion, because once that the number of variable will increase, so that our combination that will increase. So for tackling this much variability, we were not having much of what we can say computational powers and all. So and even that time also that common sense is actually impossible, nearly impossible to like program, because to work on that we need very high end sophisticated systems and all that we were not having that time. Okay, so then after AI winter, then the spring came. So after that, we were having the era of 1980 to 2000. If you see that, if you don't know, sometime that the first driverless car actually attempted by the Mercedes, that was in the back somewhere around like that 1980 or no, like it was somewhere around 1980 or some time was there. So that era we are actually was saying that the boom spring. So people have actually they have funded that the something 700 pounds and all that the million pounds and all for by Mercedes, but that was not worked out. But now today we are able to see that Tesla, even with the different companies are working on that and they're coming up with the driverless car and all. So that this work actually it started with the long back itself. Okay. Then after like then we the people started working on the like when what when the expert system came in business and hardware also, because we were having the very fixed problem setup and all that we were doing and all. Then after the burst phase came, boom. Then the burst phase came. But like that time itself, like that was the time of 1987 to 1993. That time the popularity of the PC got increased. Okay. So now, even if you see in the current now, the every people or every that the person having that so that laptop they can play with the data and then they can do the machine learning and all. So that time, but what happened that we were not getting the results because of lack of the computational power. Results were not up to the mark, or maybe the we were that facing the disappointment in that. So lack of what we can say spectacular result. And even that once that boom spring went, that burst was there, the people, the government was trying to pull out of that, and then that time now the people are even with the government are trying to like coming up with the in line with the like that AI and all. That time what happened? Like that time that even the private floor that the player was not there. So what happened? The lack of the fund also that the burst phase came. Okay. So once the burst phase gone, so it's become the consolidation phase. From where the Google came, the Microsoft came, it's age of the 2001, 2000, like that time only, that the born of what you can say Google or theory itself and call. That time the deep blue, actually, if we'll see the deep blue here, Geopardy and all that were two things were there. Deep blue, that time beats the Kasparov in the chase. So that the IBM has created that one. So that was the consolidated phase and all. So then, according to the Moore's law, also that the growth of the processing power also got increased, and the people are coming up with the pace of the AI. So it's a dead. So development in the AI and all, it's not starting like just a 10 years before and all. It started long back century, but now we are in the advanced phase, like order encoder. Even we are working in the that real world examples also. We are trying to mimic it, or we are trying to mimic the human being in a like perfect way and all. Like in this field, like China is far ahead from that the rest of the world actually. Even that the USA is trying to compete with them. Just 1 minute. Yes. Then after it was a quiet year from 2001 to 2000, but again 12. So that time that internet boom came, Google boom, that internet came, Facebook also came, large number of the data also came. Once that search engine, because the once that Google came, that people started searching, that plenty of the searches was there, so data got increased. So that time only birth of the graphical processing GPU concept came. That time that GPU and things and call, then we were getting the good results as compared to the what happened in the last one. Okay. So then we will started using of that. Then after the research focused on the specific outcome, like a general AI and all-purpose AI and all, it came in till 2012. Then the last phase till from here, that AI Spring 2012 to current. People are working with the what you can say ADAS, that's the driverless car. Like if you see the Tesla, even that Mahindra also EV also, but they're working on that, but not fully. And I recently that attended what conference actually in the TIPIT Bangalore. So Bosch is actually they're working on the one problem that they want more of accuracy. They have having the funding also. They try to fund also, like they can give the sensors. So actually they're working with the different that ODM company or maybe that automobile company and all to giving the fully like automatic car and all like the Tesla having better accuracy and all that the similar way. Now people are doing with the data mining also. Even now data we are able to collect also with the voluntary work also. Let's say captcha is there. Captcha that one, two, three, four will come. So what they will do, people will go into okay, this is the case. So now from there, that is the distributed work. So that the system will be there. So they're going to okay, for this pattern, this word is there. So that's also the data collection is there, it's going on. Okay. So till now that's going on. Now the people are working that LXNet and all, or maybe the that is the current phase that we are working on. So it was the full history of the AI, how it started from the back. Now we are working in the real time application, or we even with the driverless car, or even that we have that medical robot also. They can deal with the very precision work and all. That's all. Okay. So if I'll tell specific to the AI and machine learning, I'll tell you what is the difference between the AI, ML, DL, and all, how it's going to differentiate and all. AI is the broad area and that we'll discuss and all. So how that machine learning started with that Alan developer doing the test when it started with the during the World War II. So and then after the NN got developed in the 1975 and all, Elijah that got developed in the MIT. And then Canaan that came into the picture. That is the very they try to find out the nearest distance to like how then the back propagation that happened. Then ANN was first built in like based upon the human like brain neurons and all. It's like how that it feels, how it sense and all. Then that explanation of the based explanation based learning that is rule based, and then Q learning came. Then LSTM actually a deep learning that model we have actually it will work on the that what you can say that the long term, short term, that the memory based and all. It's a sequential problem will be there. Then the Geoffrey Hinton path of the DL came. Then the now we are working the ImageNet and all that. So CNN actually it was done in the 2012 with the help of the ImageNet and all. Okay, so can you tell these two things, human versus machine, that the geobody, yeah, IBM Watson, and actually they have played, and this game actually they have to stop. Now this game actually played in the USA, not here maybe. And this AlphaGo actually they have to banned by the company that IBM because that was that much accurate that not a single human being that able to win. So this game might be that it's a 90 by 90 chessboard will be there, or maybe that. So this is how the things human versus machine gets came into play. Geoparty. If you search with the Geoparty and then IBM Watson and all, it's a like it played gambling games and all that. AlphaGo. It was something like very perfect that even that not a single human was able to beat and all. So that's how from there theory of the comparison comes into the pictures and all. So this is the whole idea about the how that AI and the machine learning got evolved and all. So, what is the difference between the earlier till now? Like earlier, what we were having that we were lacking in the computational power, but now what we have better technology. So we have the huge computational power also, and even the data. To see that ML or AI is actually a hunger of the data. If you give the large number of data, so they're going to give the better result, better accuracy, and all that will give. And even with the democratization of the resources also, that the software and then hardware also, like GPU and all. And now the research are going with the better algorithm also. Earlier it was the probability based, like it's a naive based and all. And even with the working with the GMM, like Gaussian, that is the model that the mixture was there. So now we have the that auto encoder is there, auto generator is there, even with the self-supervised that supervised learning is there, or even with that reward based and all that everything. So if I talk about like some common terms like where the people will get confused, artificial intelligence is something any method that tries to replicate the results of the some aspect of the human cognition. It's a full idea. It's a like something called a detailed one, and machine learning is something like a program that perform better with the experience. AI, it's something that will try to replicate or to mimic the human cognition. But ML, it's a sub part of the AI. And the deep, that artificial network, it's a machine learning algorithm. It's working in the brain neurons. And deep learning, it's part of the ANN only. And big data, use of the data to find an unobvious pattern. Or maybe we'll try to, let's say, like we have the supervised learning. We'll be giving some features whether for a particular problems, whether we have the two, three types of the feature we have taken, whether it's a significant difference is there or not. So it's called big data. Like it's something finding out the unobvious pattern, whether any difference or so it's called a statistical technique. So statistical also that's going to use in that what we can say in the machine learning and all. So don't confuse with that how that AI is actually a big or it's a broader picture. Machine learning it's a part of what we can say AI only because it's specific to the it will learn with the. So this is how the Venn diagram. It's a AI, it's a knowledge example with the knowledge base. Then the machine learning it's logistic regression or maybe it's going to learn with the past experience or the history. Then we came across with the auto encoder, it's a representation learning like we'll be having, and then in that also we have the deep learning. So AI is the broader one, like it's a broader area they're going to deal with the deep learning also. Then we'll be having that is self supervised learning also, and even with the machine learning also. So machine learning is a sub part of the AI. Then the representation that learning, we have the self-supervised representation that will see auto encoder in case of once we'll go with the advanced technique and all. So that's why we should have the idea like how AI is different from the ML, and then how deep learning is going to be different from that. So deep learning it's a part of the neural network. Machine learning it's a based upon the learning. Inside the machine learning, it's a coming the inside the machine learning we have the what I can say ANN also. We have the K-means also. We have the SVM also. We have clustering also. Even with the decision tree also, random forest also. So it's all. But if you talk about the inside the ANN and all, so if with the we have the different types of the deep learning forms will be RLL will be there, GNN will be there. Like it's all it's a part of that. So that's how we have to differentiate. Like if you go to the basic that like data science or maybe that like data engineer and all that they will ask these questions like how it is going to work, or even with the some company have the ML engineer also post will be there. Some fun companies. If you are aware of the fun company, Facebook, Apple, Amazon, and then we have that Netflix, then Google we have. So that they'll ask this question. They have this post ML engineer post they have. Okay. So now the things that how it will work in the like kind of it's if you say the rule based system, input will be there, hype design program will be there, output will come. It's a AI. Okay, so it's the AI part that will be having like a hand design program, and that will do it, and then you get the what you can say AI. Then the classical machine learning input will be there. We are going to give the feature. Then we'll do the mapping from the feature. Mapping, we're going to train the model, or we'll be giving that feature importance like how it comes. Then we'll get the output. And if we talk about the representation learning, features will be there, mapping from the feature also. And then we'll be having the additional layer for the abstract feature also. Like if we talk about the ANN, we'll be having like some 64 neuron. It's like fundamental 34 or 128. That will discuss that's how this number is going to define and all. So then we'll be having two number of hidden unit. So it's a additional layer. Layer will be two layer, third layer, fourth layer. That based upon the complexity of the problem that we discuss. Then the mapping from the feature. Then we'll see the disk. That is the what you can say output will be there. So this is the how that is the like representation will going to work in the. So that's why it's the first one is the rule based that is system like a chase. That is the first one. Chase is there. They have the rule based system. Organic chemistry is there. Even with that they have the what you can say like they have the rule based system, so we can't do but anything that we have to do the hard design program we have to do. But once you come to classical machine learning, so in that one we have to get the feature. Let's say then one classical we have example like we have some different kinds of the weather is there, and what we want, what we want to know like whether the people are going to play or not. Weather conditions, cloudy, rainy, and all, and another features will be there. So we'll give two, three, four features. We'll give based upon that. We'll try to get okay whether is going to play or not, or the people will play or not. So that's how with that that's the called mapping of the feature. Okay. So now we'll come to the like how the books are saying like so, and that the machine learning, if you're going to give the using the data to the answer the question, it's something they're going to learn from the past. This is actually a hyperplane, so it's the SVM. So put vector machine that with the clear hyperplane, then that we can classify that two things we can do. So they're going to study the computer algorithms that will improve the automatically through the experience. So I'll go to the that what formally a computer program is said to learn from the experience E with respect to some class task of T and performance measure P if its performance at the task T as measured by the P improved with the experience of E. Okay. So this is the classical definitions of the machine learning that how it will work it out or not. So let's say I'll tell you the any very layman that the language and that the human can learn from the past experience and make decision of its own, so that human can make decision by its own, but machine can't. Okay, so that's the difference is coming. That is the difference. That is the very fundamental difference that we have between the human and machines. So, so if I'll ask from this person like what is this object, so what they will say? What they will say? That's a car. They're going to car, bike, bike. Then they'll say car because they have the like they can take the decision, they can tell, and even they might have seen beforehand, and then based upon the experience, it came into the pictures and all. Now let's us ask the same question to him also. What is that? But he is a human being. He can observe and then he can learn. That's how the things will. They can observe and they can make a decision. They will tell. Now let us make him learn. Show him. This is the car. This is the car. Bike. Bike. Okay. We'll show this is the car. This is the car. This is the bike. This is the bike. Now what we're doing? We are going to teach. Now we are going to give the some input to the that is the person. Now let us ask. What is the question now? What is this object? They have the past experience. What is that? Car, bike, bike. Based upon that, their description. Based upon their description. Just 1 minute. Okay. So now we'll ask the same question. So they're going to think they were having. So now, what they will say? What is this object? They will say car. So that's how that the machine that a person or a human being, that is a human being, will tell. Then what about the machine? What about the machine? Because it cannot take decision by its own. Machine follow the instruction. Okay, they will learn whatever thing, but they can't. So they can't take the decision by their own. In that only we have to give the things, or we have to feed the data, or to train the machines to take the decision, because they'll follow the instructions. Not like so they can't take decision by their own. So we can ask a machine to perform an arithmetic operation, addition, multiplication, division. So machine will follow the instruction. Let's say I will ask like just say 2 plus 2, 4, or 2 into 2, 4, or maybe 2 minus 2 is equal to 0. So what they will do, they will follow the instruction. What about the machine? They will do the comparison, or maybe they are going to what are the input, what are the output, and then based on that. Then we have the print and plotting a chart. What they are doing? Machine following the instruction, but they can't take the decision. How they go? So we have to give the input. Just 1 minute. And anyone tell like how the things are going? Shall I speed up a little bit, or either this is okay? Please, anyone? Fine. Okay, I'm just why I'm going to the slow, bit of slow. Uh, like I'll just make you sure you should have the idea how the things will work. Once we'll pace it up with the linear algebra and all, that will go ahead with the solving the problems and all. Okay. So what the machine will do? They're going to follow the instructions. They don't have any like to capability to take the decision by their own. Okay. So now we want a machine to act like a human. We want a what is the machine learning? What we do, we want the machine learning to act like the human. So to identify this object, now this is the machine and this is the object, because they don't have the idea, so they can't tell what is this until unless we're going to train them, or we'll tell them. In the case of the human, they have to capacity to take the decision and all. They can do so they have done it. So now here in the for the machines, they will doing the some sort of basic operations and all that they will do, because we have done the programming for that. Now we are saying to identify the object based upon now what to do. So we have to give the features, or maybe the descriptions. Let's say I want the things like this is the this is something called mouse, but the machine doesn't know like how it look like. So we have to tell, okay, for this we'll be having this size will be there, or this color will be there, this weight will be there. So similar way we'll be telling, giving the features or description of that particular object so that that the machine can act like a human. What they will do? Predict the price in the future. What a machine learning will do? Will we get to know that they will be going to predict the price in the future. Even what they will do? They are going to understand the language and correct the grammar also. Yeah. They are going to that they are going to understand the natural language and correct the grammar also. What the machine learning will do? Recognize the faces. How they will do it? We need to provide the. So this is all examples that we have. They can do the predict the price of the future. It's called forecasting. Like it will be coming under the regression and all. If you see the time series problems and all that we can do, even they will be doing with the text recognition and all. And here now it's a recognition of the face, so it's working with the scene and also because if you see with that like image, it will be RGB based, and we don't have the ideas of because for the input of the machine learning that we need to have the vector or they need the number. They can't read directly to the like so we have to give some sort of a 64 by 64 or maybe that what we can say that the matrix we have to give. So how what do we do like for a machine to act as a human? So we need to provide what experience to the machine. How we will do it? We are going to give data or training data set so that we'll provide the training data set to the machine. Then we'll be giving the some respect or maybe their descriptions and all. Then this device algorithm and execute the program on the data, like based on the list of something called mapping. Before the mapping, we have to give the feature, input feature, output feature that all that we have to give it out. So that's how it will work it out. Then using this program, they have to required rule, identify the required rule. Then after they're going to extract the pattern. So this is the whole process. That's how it's going. Because we have to train, we have to let the machine get experience so that they can behave like a human being. Okay. So what we'll do, we are going to feed the data. We'll be giving the features also, and then we are going to execute the program so that just 1 minute. So then after they're going to identify the required rules. I'll tell you what is the difference between the how the other traditional problem or that the programming work or the machine learning how it work. So extract the required pattern. That's how we'll get it. Then after identify the relations based upon the description or features. Yes. Okay. So then after, so that machine can drive the interference or they can tell like what is the work and all they can set the rules. Then after once we'll give the same data set, they'll be able to behave like a human being. So what we do, we have to get the machine, get the experience. Then they will give the better performance even with the human being. So what we'll say, if we see the summary, giving a machine learning problem, identify and create the appropriate data set. First step is to have the data set. Then perform the computation to learn required rules, pattern, relations. It's something called features. If anyone is the peer score or not, that if they're going to work on the data, so we'll be having a raw data. Then we'll do the pre-processing. Pre-processing like cleansing of the data, cleansing or removing the redundant data. Then after, we'll calculate the feature. If it is supervised learning, we'll get the features. Then we're going to train the model. Then it's going to execute and all. Then after output will take as a decision and all. It will come. So this is how the things will work out for a machine learning. So that's how for the full course we are going to deal in a different algorithm, and even we'll do the that parameter like that optimization problem also will check. And if we talk about the what is the types of the machine learning, first is supervised learning. We're going to give this is classified binary classification, multi classification. We'll tell this is trend, this is untrained. We'll give the features. Then we'll ask to classify whether how good they're going to classify and all. Then we have the unsupervised learning. We that we don't have the feature that the label will be not there, no label. Here labeled feature. Reinforcement learning is something called reward based or penalty based. Okay. So that's how it will go work out and all that it will go. So if we talk about the classical programming, we have the certain sets of rules will be there. We have there some certain sets of rule will be there. Is it? We'll be having some certain sets of rules will be there. Then the data we are going to feed it out. Classical programming. Then we are going to give the answers. Even in the machine learning, what we did, data is there. Whatever data we have there, even the answers is there. Spam, not spam. What they will do, based upon this, they are going to find out the rules. In the classical programming, that what people have done with the that the IBM that Geopardy was there or AlphaGo was there. They have the certain rules was there, and so they have the data, so they were able to give the answers. It's a rule based. Now for the machine learning, what is that? Data is there. Even we'll get the answers also. Now we are so we are asking the machine learning to behave and then set the like some such that the certain rules when they're going to give the unseen data or generalization, it's going to help or it's going to predict. So they're going to mimic as a human being, is it? So that's how the difference between the classical programming with the machine learning it is there. So that's how we have to think, and that's how the machine have to think about that. So here we have the rules, we have the data, then we'll get the answers. So that the certain things that because the chess, so that is the fixed rule is there. But then the data will feed it, we'll get the answer whether so they're going to win either the machine got to win or either the person got to win. But now here I'm saying data is there. This is the data that we have. Now we'll tell okay for the spam detection that the classical example actually is there. Now we'll tell this is the spam. One mail is like we have the some thousand data set is there or the mail is there. 500 that is spam. 500 is that that's going to be not a spam. Now we're going to based on that. So they're going to fix a rule. Once we'll give the unseen or without labeled data set, so they're going to give the accurate or accuracy will be the good and enough. That's how the machine learning will work. So that's how the machine learning will going to work out and all. So, but when is the machine learning going to useful? Don't use it when the rules and that the rules are very concise and clear. When we have the chase problem, or even we have a organic chemistry problem, is it clear? So whenever there is a hard rule, or we don't have like we are very much clear about the rules and all. So in that case, we should not use the machine learning. When we have to use when expert are unable to explain their expertise. So it's something that will give them some pattern, unobvious patterns will be there. Now we are trying to get the things like when like to get the extract data when image recognition and all speech recognition and all driving and call it's a drive like driverless or ADAS and automatic and all will be there. When human expertise does not exist, let's say they're going to hazarded environment navigating on the Mars, or maybe that the bad. So that's what you can say. That's the bad weather. Bad weather. Let's say we have heavy rains are there because once we are doing the training, even though with the experience, people will get learn more and it will become the good drive. But still, we are not much of trained for the that's called storm or heavy rains and all. In that case, a sensor or any automatic machine sensor, they'll play very like carefully and all that we can get even with the compared to the human beings also. And then after we have to solution need to be adapted to the particular case, user biometrics or patient specific treatment also, because we know that for this type of the system that is symptom, so that is going to be a disease will be there. For that disease what we have certain treatments are there. So in that case also that machine can adapt some certain that what you can say particular case that they need to adapt, so they can do it. That's the user biometric also. With the time, morning or evening, the punch out punch in will be there, so that's going to help it out or not. So I'll we'll see some mathematics in the most ML. Like all problems are data. That is number. All solutions are functions or maps. What is there? So whenever we talk about any of the ML and all, so if you see the image is a data set. But the thing is what a machine that required, they need the numbers, is it? Because the machine is going to only recognize either one or zero, or even not the molecular classification. That's how. So it's a numbers. They don't need that exact how things are going on. They need the numbers how it will go into. If you see the image, so that's why image. So we have to convert into the like a tensor, like some sort of pixel, and that will going to give it. So we must convert this qualitative input into the number. It's called input vector. Similarly, the output that human give must be converted into the numbers itself. Whatever the input will giving as output also, or the features also that we have that we have, so that we have to give it into the input vector. Vector means numbers. Determine the appropriate input and output for machine learning task is essential part of the progress. Let's say sometimes we'll give the raw things and all. If we don't give the numbers, they're not going to mimic or anything. So task often the learning task is the learning the mapping from the desired output or input of output and all will be there. So that's how in the machine learning, whatever data we have, image or speech and all, we have to convert into the numbers. Numbers in the machine learning that we have to convert into the tensor, from where that we have to get to know that where the algebra that algebra is going to work it out. Okay. So if we talk about the types of the machine learning, can anyone tell what are the types of that the machine learning that we have? That we have discussed already, I think. So better we'll go ahead with it. So if we talk about the machine learning, so we have that the majorly three types. It's a supervised, label data, direct feedback, predict the outcome of the features. Either with the so that if we talk about the machine learning, it will work as either classification, either prediction, or regression. That can be done for the all thing. Classification, it's going to be a class classification. Let's say I'm going to say trained participants or untrained participants. Predictions is something I'm going to predict the fatigue with the time evolving, how the fatigue is going to happen. With the time it's going to flow, that how that uh, energy consumption is going to increase or decrease. So that's how two types of the problem that are going to work on it, either classification, either predictions, or the regressions will be going to work it out and all. So then what we have those, so that will be the unsupervised learning. Unsupervised learning is something called, it's going to be a no labels, no feedback, find hidden structure. Is it? When we have the reinforcement learning, it's the decision process, reward system, learn series of the action. It's going to work on the reward and penalty. So that we will discuss. It's advanced machine learning will tell in the last 2 weeks that we'll discuss. So now we'll see like how the things are going on all that we have the machine learning. We have the classical learning that's called supervised, unsupervised. In the supervised, but we have the classification, KNN, naive-bayes, SVM, decision tree, logistic regression will be there. Okay, so it's the class two class. Sometime binary classification, or even with the multi-class classification will be there. Okay. Then we have the regression, linear regression, polynomial regression. Then we have the lasso regression or ridge. That's we'll discuss in detail in the coming part also. In classical learning, we have the unsupervised learning. Clustering will be there. DBA scan, agglomerative, K-means, man shift, fuzzy C-means will be there. So that we'll discuss in the like detail also. Then pattern search will be there. If cleared PG like FP growth, a priori will be there. Then we have the dimension that the reduction will be there. Sometimes the sometimes what we'll do, we're going to work on the higher order dimensions role. So what we'll do, we are going to use the TSNE, PCA, that the principal component analysis, LC, SVD, LD, and all that will work on to reduce the to reduce the dimensions of that. Let's say it's a 4 by 4. We want to do 4 by 4. We can convert into a 2 by 2, 3 by 3, so that it will be going to useful for the machine learning or the algorithm to learn and give the results. If you give the higher order tensor, it means they so the complexity is going to increase. It means they are going to work more on that. So our computational cost is going to increase. Okay. So that is the called classical learning that we have. Then we have the reinforcement learning. It's that I told earlier. It's a penalty or reward based learning which we have. In that also genetic algorithm, A3C, SARSA, Q learning, and then deep Q network will be there. Then we have the ensemble learning, stacking, bagging, boosting will be there. AdaBoost, XGBoost, like GBM, CatBoost will be there. Then we have the we because the in the after discussing the fundamentals and all that will go into the deep learning, and then that's the neural. So that's the neural. So that's the network will be there. In it we have the MLP, multi-layer perceptron, CNN, CNN that is going to deal with the image one. Then we have the RNN. It's called sequential learning will be there. Then we have the generative adversarial. That's the network is there. Then we have the auto encoders are there. So this is the overall types of the machine learning that we have. So that will mostly that all things will that discuss and all. This ensemble method that we'll see once the time permit that will do it. So what are the basic steps in the machine learning? I think now we are running out of time also because we have to deal with the some sort of we'll see. So that the seven stage of the machine learning, a simple workflow. Like it's a first step is to source and quality. Data collection will be there, data preparation, clean and transform. And like we have to reduce that noise or remove the redundant data. Is it? Then we so then we'll go based on the data. It's that is supervised learning, that is unsupervised learning, or maybe reinforcement learning. So we're going to choose the ML model. Then we're going to give the parameters, training the model, how the things will go. If it's ANN, 2 layer, 3 layer, 4 layer, or maybe the number of neurons will be how much, number of that the hidden unit, how much, and all that we'll see. Then after it's going to model evaluation, whether that we have done training, whether it's got properly test performance and all. If it is done, so we'll do the model improvement. If there is any room to improve the performance, we'll do. It's called that is the hyperparameter tuning, or maybe optimization. Also, we can say. Then we'll do the predictions or either the classifications, and then same thing can be done deployment or interference also. That's how this is the stages of the machine learning. That's how it's work and all. So if you see that I told like how it going to basic the two types of problem that will going to work in the supervised learning. First one is the classification. Regression is the fit. Split it, fit it. Discrete or category data that I told 1, 2, 3. Or fit means it's a regression problem. Means there should be error should be less, and here accuracy, that how accurate a number or how accurate a that the machine learning that model going to classify. Here that our error should be less. Like whatever the ideal line and data fit data should be closer to the ideal line should be there. So that's how. It's a has category associated here. Associated numbers will be there. Then tumor classification, whether tumor is there or not, that the whether cancer is there or not, whether participants are trained or not, whether the fatigue happen or not. Here, that stock might that the market predictions, or maybe the forecasting also, or maybe that the how fatigue is going to happen also. That we can check it out and all. Okay. So now this is the whole idea. Like we have introduced the what you can say, that's the machine learning and all. So that's now the for this course we are going to use the linear that's the linear algebra from vector to vector. We are going to use, and we'll do some transformation also, like transpose, eigenvalue, or the norms, and all. We'll check it out. Then we'll check about the data result have uncertainty to built into them, because there is always chance will be that there is an uncertainty will be. That's when the real world problem will work on. So there is uncertainty will be there. So that's why that's why the probability will come into the very into the picture. So we should have the idea linear algebra. We should have the idea about the probability also, and even we have the idea we should have the optimizations also. Okay. So optimization will be it's something. So for a given set of data, what is the best model? What is the best parameter? So that so that their accuracy, that the level of accuracy that for a model it should go increase, or it should give the how accurate the results are giving. So that we can do through the optimization also. That is through the optimization. So this coming 2 3 week that we will discuss more into the algebra, probability, optimization. Then we'll go into the our something called neural network. And so why linear that algebra is going to be useful, because that input and output both represented as a vector, like because the a machine or a model that required the numbers. So by vector, we simply mean a collection of the numbers also. So part of the problem, they convert the seemingly qualitative input such as the picture, sound, color into a number. So that's how that the linear algebra will work. Okay. So while that linear algebra is going to be useful, because that I told, because it's going to give a black image will be there. From that we are going to convert into the matrix. This is the two images that we have. From there, we're going to convert into the matrix. Then it's going to, this is the black box. Here, it's going to work out like a that model. Now it's, let's say it's a ANN or like a deep learning and all is there. Then they're going to give tensor. This is called tensor. And this is going to give into tensor itself. Then we have to convert into the again what's happening and all. Okay. So if we talk about the black and white image, so we can give the same intensity for the full image. But if we talk about the color image, so it's an RGB pattern will be there, red, green, blue. For that different intensity that will be there, and then we have to define a tensors and all. So that's how why do we need the algebra? Algebra is a very integrated part for the machine learning. So if I'll be telling you to just go on first year of first semester maths will be there. That's with that their algebra, or even with the 12th math also that will be going to useful for you. Okay. So it's in that what we all know that what's how we are going to like transform deformations or decomposition of the matrices and all that all do and we have done. So if we talk about the linear algebra, so we'll be having, because in that we'll be not going to much of more discussion regarding that full that algebra system of the linear equations and all. Mostly we'll be going with the scalar, vector, matrices, and tensors. So scalar is actually it's a number. It's something like it's a learning rate we can say. It's called a zeroth order tensor. We'll tell like how it will go. Zeroth tensor. Vector. Vector will be the array of the number. One, two, one, two. The numbers are arranged in the order. We can identify each number by indexing that ordering itself. So vector, it will be always scalar will be the single number will be there. There will be no array of the number that will be there. So now the matrices will be the two dimensional. When I say that vector, it can be of 1, 2 itself, even 1, 2, 3, 4 also. So it's a like vector. But if we talk about the scalar, it's going to be like s belong to real number and it's going to be single number only. 1 or 2, that's all. If we talk about the matrices, what we have, we'll be having two dimensional. Means there
Sir,
is going to be a,
actually,
yeah, sorry.
I have a little confusion regarding vectors.
Yeah.
Is there is must be a necessary condition? It must be only single column.
No, like not like but scalar is just it's a single numbers will be for the uh, scalars.
Scalar is just a single number. I
Yeah,
agree.
yeah, yeah,
Zero order tensor, but in
yeah,
case of vector, it
yeah.
must contain only single column.
No, no, no. It can go like a once we have to like to follow that so that the rule of tensor. So it can come 1 0 0 0 0. So it's something that will come. Is it clear or either I have to explain again?
Sir, fi- uh, then in case of matrix and
Yeah.
in case of vector, is there any difference?
In case of like that vector can be of one dimension or the matrix it should be have two dimension. Like
Yeah, yeah.
either so that is the difference will comes into the picture. That vector it can be of one by one itself, but the matrices will be always two by two, two by three, two by four, something. It will go.
2D array is called matrix,
Yeah,
correct, sir?
yeah, 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 yeah. Matrices.
Okay.
And the tensor will be whenever that will be having a dimension greater than the two also. Let's say tensor if it is a scalar. Let's say if it is a scalar, that we don't have the vectors. It's called zeroth order tensor. Like a five a single number will be there. Let's say the vector. It's either 1 2 3 or maybe 1 2 3. It's a one dimension. Like it's a first dimensional tensor will be there. Matrices will be the second order tensor will be there. 3D tensor, nth tensor, it will go as such as it will go. So in the case of images also, it's going to be a n or n type of that dimensions and all. If we talk about like AI, let's say 1 2 3, even though it's a first order tensor, if you talk about the dimensions, it's going to be 1 2 3. Dimensions is different and order is different. Whenever we will be having two by two, or maybe that the matrices will be there, it will become the second order tensor. But in that case, 1 2 3 4, that 1 2 3 4 will be the dimensions. So that's how it will go, and it's going to work it out and all. So tensor, it's called multi-dimensional array. Let's say it's going to vector, it's going to be like one single array will be there. Matrices will be going to 8 by 8 or 2 by 2, 3 by 4. It's something called, we'll be having like more than one. Or it's a two dimensional. And the tensor, it can be of like multi dimensions also we can say. Like let's say we have the images are there. So RGB will be there. For R, we have the different grids. That the grid, let's say 48 by 48. I'm taking for the R. For the green, I'm taking for the 60. So that based upon the intensity of the color will take 64 by 64. Like it's not 64 by 64. Then blue, I'll take 32 by 32. So it's a multi-dimensional tensor will be comes into the picture. Like it's to be uh, one matrix again here, one matrix again here, one matrix again here, that matrix again here. So it's a multi-dimensional tensor which comes into the picture now. Okay, so this is how I think we are running out of time. So if you see that basic operation for the linear algebra that we have done addition, broadcasting, multiplication, transpose, and inverse. I think you might be all knowing that how it will going to work it out. Let's say A plus B, it's going to be like we'll get Cij, like Aij plus Bij, it's going to Cij. Though, so that order should be same. So that is going to valid for the both addition and subtraction, is it? Then the third that we have the broadcasting. So let's say Aij, it's a m by n, and we have the something called like b is there, and we'll get the Cij only. So in that case, let's say it's a one by one. So we'll add the identical number. It's going to be like we're going to broadcast. Bj is the vector. It's a vector only. It's not the scalar. It's a vector only. So what we'll do? It's a m by n. We'll get the m by n also. What we'll do? We're going to, let's say example, it's a 1, 2, 3, 4, 5, 6, and we have the b. It's a 1 minus 1, 1. So what we'll do? A plus b. That's a b. So they're going to this also, this also. So it will come 1, 1, 2, and 2, 1 minus 1, like it's a 1, 3, 1, 4, and 4, 1, 5, 5 minus 1, it's become 4, 6, 1, 5. So it's something like we're going to repeat it. So adding a vector to a matrix to repeat the vector. That's all. So it's called broadcasting. Broadcasting that we are going to just repeat the vector. Now in the case of A, if we do the A transpose, so it will become what you can say. Let's say 1, 2, 3, 4 was their A matrices. So now it will become the Aij to Aji. So that's how the transpose will go. Inverse, anyone can tell like how it will go?
Yes, sir. It's a lengthy process. First, we have to
Yeah.
calculate the determinant of matrix and
Then the
and
cofactor and all.
covector and transpose also.
Yeah. So
Divided.
before that, what we'll do? Inverse. Let's say if it is A inverse I, and then A inverse. So that's how it will go. And this is the transpose and all that you can see here. So if you see the matrix from the next class, we'll solve this problem into the directly matrix itself. Okay. And A inverse and A, it's going to be that not all A square matrices have the inverse. So for non-A square matrices that we can have the pseudo inverse also. That we will discuss in the detail also. I think we have much of a spent in the intro to, because we were supposed to have class for the first that week only. Today we could have done with the full more into that problems and all. Okay. So then what about will we having that matrix product also? Matrix product. Is it? C is equal to AB, Cij. It's going to be summation of K, Aij, Bkj, or it's called Jk. So how it will go? Let's say C A into B. So M by N, it should be inner should be match. Is it? So that we get M by N. So inside matrix that we should have, like it should like side must match. What about the dot product? Or shall I go and solve the problem directly? Let's say we have the two vectors are there. We'll get one scalar. If you have the idea like how alpha is going to a to the power t b or b to the power transpose of a, that rotation. So let's say a and b. So a1 b1 plus a2 b2 plus a1 like it's a2 b2 plus a3 b3 till a and bn. So we'll get a one scalar number. Is it? Transpose we have seen BD power A and then it will come like behave like this. And then inverse also, yeah, that identity matrix will be 1 0 0 0 1 0 0 0. Then we'll come to the norms. Norms, anyone have the idea how what is the norms? Norms. Norms is something that we are finding out the length of the vector. Mesela we use the tensor to the basic unit of the representation, like it's a vector and matrices. So that why we are using the norms, like how big the vector is there, and then how close the vector. If you see that close, it's the kn in matrix with this. In that case, we're going to use it out. Like if you have uh, like uh, like one,
Euclidean distance.
yeah, Euclidean distance with that the coordinate geometry. It will be always a single number. It's the length of the vector we're going to find out. Is it? For a alpha, it's a scalar. If you're going to double alpha, it will come called the norms. For a vector, for a vector 3 and 4, it will come 3 square, 4 square. It's a Euclidean distance, we'll say. Okay. So what is the definition? What is the definition of the norms? It's a norms are a way of measuring the length of the vector matrices. And some sort of standard norms are there. That will be fx is equal to 0 at x is equal to 0. It means this point. And they're going to follow the triangle inequality. Let's say we have three. Let's say this is we have three, and this is four. So this is going to be a 5. So ff of x plus f of y, it should be greater than of f of x plus y. Y fx 3 4. So this is called triangle inequality, we can say. So that is going to follow the norms also. What about the linearity? It's going to be a call f of x directly, like it's going to multiply with the full vector. Let's say I have 4x plus 3y. So we're going to apply with the 5. So 4 into 4, 16x plus 12y. So this is going to follow the linearity and all that are going there to follow. Okay, just 1 minute. Okay, so then after that we have in the machine learning that we are going to use the Frobenius norms. Shall we stop by today? Like then we can discuss in the next class from here only. Is it? Hello? Can anyone reply?
Yes, yes, sir.
Yeah, like then further we'll be having to discuss about some sort of combinations, and we'll go the decomposition also, transpose, or maybe that what you can say that I, that the quadratic forms and all. Then we can see the problems and all that we'll see. So can anyone tell like how the sessions and all, or where to improve, and then where you can interact with me?